Put your phone number, mail ID. I'll pass those recordings to you.
Sure.
Last 2 days recordings so that you will be comfortable. Okay. Yeah. Mail ID also, please, Rohit. All right. So we were talking about artificial intelligence and machine learning, right? Artificial intelligence and machine learning. So what is artificial intelligence? It is like a broad field and which is mainly used to transfer human intelligence to objects, where objects will become artificial intelligence objects. Artificial intelligence objects by writing machine learning algorithms. So algorithm is nothing but a code where we have a multiple types of artificial intelligence like narrow AI, general AI, super intelligent AI. So narrow AI means weak AI, where these are used mainly for small tasks like playing chess or recommending movies. General AI means this is the main usage of artificial intelligence. That is where we work on uh, reasoning, understanding, building intelligent chatbots, predictions, recommendations, categorizations, classifications, estimations, fraud detections. So all these major ones. The super intelligent means like a satellite controlling. So these are the multiple different types of artificial intelligence. Okay, that we discussed yesterday also. And AI techniques are rule-based systems, the machine learning, then NLP, natural language processing, then computer vision. So we will be working with the machine learning based AI and NLP related AI, right? So what is the machine learning? That is where we started. I told you the artificial intelligence can be achieved by writing a machine learning algorithms. But before that, what is a machine learning algorithm? How to work with a machine learning? So machine learning is nothing, learning, machine is nothing but a computer. Learning is nothing but execution. Learning is nothing but execution. So algorithm is nothing but a code. Once this code executes against the data, that becomes a learning. Once the machine learns, that becomes a model. The model is learned algorithm. Our algorithm executed on the data. That model has some information already. It knows what kind of usage you are working on, what kind of data you have it, because we have trained that model. Once the person is trained, that person will be skillful, will be able to perform a task. Similarly, model is nothing but skillful person, a skilled person. So this model, skilled model, can be used to predict something, estimate something, categorize something. Okay, understood now what is the model? Anybody has any doubts? Are we clear? Let me ask this. Are we all clear?
Yes, sir.
Okay. Okay. 1 second. This is okay. So now we are clear about model. Now, how machine learning algorithm behave? Here, machine in this case is a computer. Learning refers to an algorithm. This algorithm that's repeated over and over until certain set of predetermined conditions are met. Repeated over and over until certain set of predetermined conditions are met. So there are already some conditions defined. Those conditions have to be satisfied. Until these conditions satisfies, the algorithm what you write the code will keep running on the data again and again. Or learning algorithms are generally run until the point the final analysis results will not change. No matter how many additional times the algorithm is passed over the data. So if it is a normal program, a normal program will take some input, execute once and generate output. But machine learning program, it takes input, run again and again, multiple times, generate output. That will be n number of times. The machine learning algorithm will execute n number of times like this, continuously. That may be 10 times, 15 times, 100 times, million times. That we don't know. Till it identifies the results, required results. Or till it matches the predefined conditions. So this is called iterative. Iterative means executing algorithm again and again. It's different from normal programming, normal coding. Are we clear?
Yes, sir.
Any questions? Let me go one by one. Akila, any questions? Sai Kumar, Divyasri, Saumit, Guru Chaudhary, Jansi, Manvita, Banu, Naveen, Pranay,
No, sir.
Raghav, Rohit,
Yeah, I'm good. Continue.
Srikanth, Kamsi, Venkat, Vijay Kumar.
Sir, when you say machine learning is nothing, algorithm is nothing but code.
Yeah.
Do we need to learn the codes?
Yes, we are going to learn the code.
Okay.
It's all theory, right? This is only a third class. So still not entered into hands-on. Okay. Right. So now we are clear about machine learning. Definition. We understood the machine learning. What are the different types of machine learning? So one is supervised machine learning, unsupervised machine learning, reinforcement machine learning. Supervised machine learning is classification, regression. Within the classification, we have different, again, varieties, types. Based on the use cases, we will be using these types. Navier Bayes, decision tree, SVM support vector missions, random forest, k nearest neighbors. These are the classification algorithms. Then another one is unsupervised. So within supervised, we have again regression also, linear regression, SVM regression, decision tree regression, logistic regression. So these are all the different varieties, all these varieties under supervised. We will discuss what is supervised learning, what is each algorithm, theory and coding. Okay? Just initially try to understand the terminology, try to be familiar with the new terms. Take some time. Okay. So apart from class, you should also spend some good amount of time to be able to understand all the classes. So otherwise it would be little difficult to follow if you don't spend time after the class. Okay. Unsupervised learning, where we have a clustering. Within this, we have again k-means clustering and hierarchical clustering. These are all the different varieties of types. Then reinforcement learning, where we have a decision tree like a Q learning, R learning, TD learning. So these are all the different algorithms. So we will be discussing in part of machine learning. So the machine learning is implicit for generative AI. So as I told you, let me show you that. Look at this one. This is our main objective. Our objective is to create new generations like a text, images, video, code, music, speech, or whatever it is. For that, we are trying to work on generative AI models. This one, Gen AI models. These Gen AI models internally built with machine learning algorithms, what we discussed just now. Algorithms like supervised learning, unsupervised learning, reinforcement learning, all these are inside this generative AI LLM models, large language models. LLM, large language models. Those are implicit. But what we see is explicitly LLM, large language model. Now, we started with the machine learning models, implicit models. What is their functionality and what we need to work, where we need to work to build these LLM models. Then we'll go to prompt engineering and all that. Clear?
Yes, sir.
Okay. Now look at the usage of each one. So here you see supervised learning. This is one of the types of machine learning, supervised learning, where we have a fraud detection, image classification, customer retention, diagnostics, then forecasting predictions. These are all part of supervised learning. Another one is unsupervised learning. There we have a dimensional reduction, clustering, that's like a customer segmentation recommendation systems, and reinforcement learning, like real-time decisions, robot navigation, skill acquisition. Okay, so these are the three different types. These are three different types. Then key components of ML. So which are features, which is a very important one. Then the labels, model, loss function, optimization algorithm. So whenever you want to build any machine learning model, you have to be comfortable with these components, like a features, labels, model, loss function, optimization algorithm. The features, what we require. What is this feature exactly? Input variable are attributes which are mainly used to make predictions or decisions. What is this one? Input variable. For example, you are given a task to predict, how many employees are going to leave my organization in next 3 years. That is a task. That is a prediction. Okay. For that, you require some input data, right? What is input data you require? Employee details, then employee discussions. Then where is the employee discussions? In social media, okay, or dialogues with HR. So these are all the input attributes or input variables which are going to be feeding to machine learning algorithm in the form of features, so that machine learning model will try to predict and will try to take decisions. Got it? Okay, forget about this one. If I give you a task, let's say I'm going to launch my new product, then I'll ask you, can you estimate my product price? If I say that, you start asking questions, input variables, correct? Number one, what is the quality of your product? Number two, which location you are going to launch? Number three, what are the other unique features when compared to competitors? Correct? Another thing is, what are the user manuals to train users or consumers? For every product, there will be user manual. So these are what? These are features. Without features, the machine learning cannot do anything. It doesn't predict, it doesn't estimate, doesn't categorize, doesn't classify. It always requires some input variables or attributes. For this, I'm giving it a name like a features. Anybody has any questions? Got it?
Yes, sir.
Then more labels. So what are these labels? Labels are the output variable or target variable to be achieved, like output of model prediction. Then class of categories. Let's say we have a bunch of products. You are asked to categorize it, like products categories, like groceries or appliances or interiors, like this, the categories. These are called target or output. Fraud detection, output, target, that output variable. Fraud happened or not happened. Okay. Then model, mathematical representation or algorithm that learns patterns from the data. So mathematical representation or algorithm that learns patterns from the data. Loss function is like a measure of how well the model predicts the target variable. Like difference between this target variable and predicted variable. That means actual and predicted. You say the model predicted value is 10. That means it's supposed to give 10, but after execution, it is giving value 5. The difference between 10 and 5 is the loss function. The difference between actual and predicted value is loss function. So whenever you have a less loss function, the model is more accurate. So our main objective is to optimizing or reducing loss function. By reducing a loss function, you optimize algorithm, machine learning algorithm. Okay, so these are the key components of any machine learning algorithm, whichever you take. Any questions over here?
So, in loss function, there is if you order something in the any branded applications like Amazon something, while we add after purchasing the price calculation may be different. So while after discount or something,
Correct.
this is
Yeah. What you predicted and what it actually given. That's the difference is loss function.
it was showing something around 100 rupees. After adding and placing the order, it's showing a different amount. You were saying that thing, no, sir.
That is the difference. That is the different thing. That is the marketing techniques. I'm talking about machine learning. Let's say you have developed a machine learning to achieve 80% accuracy. Okay. Your intention is to provide that machine learning model accuracy 80%. But after developing and running that model, it is giving a 60% only. What it's supposed to give?
It has to show 80%.
Exactly. But what is it is actually giving after running?
60%.
What is the difference?
20% is
That is the
saying.
last function. That is the last function. Still, there is a gap, right? So we have to increase that 60% towards 80%. You go back and work on the data. You go back and work on features. Those things.
Okay, sir. Got it.
Got it? That is the difference. Last function. So look at this one. This is one data set. What you see my screen. You see some fields: instant, date, day, season, year, month. So this is like a daily bike share, like how many bikes you can give to rental. That is a use case. For that, whatever you see on the top, these are all the fields. These fields are input fields or features, what you see here. Same thing, I'm calling it as features, input variables, attributes. But what is the label here? Output variable, target variable, or model predicts. Prediction is rentals. How many bikes you can give rent on daily basis. That is output. Target 10 bikes, 20 bikes, 30 bikes, 100 bikes. So this data is historical data. What that fellow has been renting from past 10 years. Now he wants to predict future. How many bikes can be given on rental basis. So for that he needs a model, machine learning model. You tell me what is the output variable here? What is output variable?
Rentals.
Correct. Exactly. Rentals here. Okay. What is input variable? What do you require? Forget about machine learning. If I ask you the question, boss, I have a bikes company where I have 100 bikes. I've been running this 5 years. Now I want to predict the future next year, how many bikes I'm going to give it for rent. What is the question you are going to ask me back? Boss, you tell me last month how many bikes you have given for rent? Or in rainy season, how many bikes you have given? In summer, how many bikes you have given? And where are you located? Are you in a prime place? Okay. Are you available for people? These kind of questions you ask, right? Those are the input variables. Features. Here I talked about features. Those are the features. Rentals, what you are trying to achieve is target output variable, which will be the outcome of model. Got it? Model is nothing but math algorithm. Algorithm which learns patterns from the data. What patterns here? In summer, weather, rainy season. Okay. How many bikes were rented in the past? In so and so year, let's say there is a COVID time, 0 rentals. Soon after COVID, again went up huge number. Before COVID, normal number. So that like this, there will be some spikes here and there. We need to consider those spikes, historical data also, to predict it. So those are the input variables. Then machine learning algorithm learn those kind of patterns. How this behaved in COVID time, before COVID, after COVID. Some data points, data insights, patterns, data patterns. Working day, how many bikes? Holidays, how many bikes? That is called model learning. When you run algorithm against this data, that algorithm learn and keep it with it. When you ask question, it will answer it. Got it? But that answer, how accurate? How are you going to measure? In the form of loss function. What is supposed to predict? That bike owner that fellow, bikes rental owner, that fellow says, "Boss, I want you to develop a machine learning model which can predict at least 90% for me." Then you have written a code, you gather the data, labels and everything is all right, executed the model, but that is giving only 60%. What that fellow is expecting, 90%. What is the difference? 30%. 30% is the loss function. Now, your next activity is reduce this loss function. Increase that 60% to 65, 70, 75, at least closer to 90% by working on these features. Let's say you forgot to gather weather information, or you forgot to gather COVID information. Correct? That will influence the machine learning model output. Yeah. Any questions, please? Sudhakar, any questions? Are we good? Vamshi?
I just joined probably. I need some
Okay.
more time.
No problem. Surupa, Rohit. Anybody not posted your phone number, mail ID, please post it again in the chat. In case if we forget, I'll share these sessions. Okay. Then features means here. Yeah. Anybody has somebody raised hand? Okay, fine. So features means you don't derive a features just like that. There is a mechanism inside this. So mechanism means if the project is more familiar to you, you will be having idea about features, or you'll be having idea about variables. But if the project is not familiar to you, like medical industry, drug discovery, you are not a druggist or you are not pharmacist to identify what are the variables in it. There will be a lot of chemical related variables, right? And there are scientific variables. That is where you need expertise. That's where you require a feature engineering. So feature engineering is another concept in the machine learning. There we have a different techniques for feature engineering. So those techniques are like this: selecting a features, transforming a features, creating a new features from raw data to improve the performance of machine learning model. Then it includes like data pre-processing activities, feature selection activity, dimensional reduction activity. We will discuss all this, and feature scaling activity. Excuse me. Look at this one. Here in the data set, you are given a weekday. Assume that working day is not given here. You missed it somehow, but you are asked to derive working day. So based on the calendar, based on the holiday list here, you'll be able to derive working day. Working day was not there initially, but you derived this working day. This is one of the techniques of feature engineering. You applied your own techniques and derived this feature, extracted this feature from existing features. Got it? So if you have a holidays list, you'll be able to derive a working day. Right? Yeah. Or you may combine two fields and derive one new feature. You may combine two fields and derive one new feature. For example, I want to derive a excuse me, date, but you are given a day, month, year individually. You can combine all three and that will give you the date. That becomes one new feature. So like this, you start deriving a new feature. Or look at this one. In this data set, you will see other fields, working day, weather, temperature. But to attract youth, say we have not given a model, bike model, like latest models. So that may attract more youth. That feature will influence the model output. You are going to include type of bike, model, or whatever it is. Got it? So like this, you worked on these kind of techniques and derive a features based on the functionality. That comes with experience, and the more you work with the data, you will be able to understand it. Got it? Here, you derive a features based on the techniques called data pre-processing technique, feature selection technique, dimensional reduction technique, then feature scaling technique. The next step is model evaluation and validation. Okay, you said model is to predict bikes, rental bikes. How many bikes? If model says you can give only 10 bikes next month, or 5 bikes next month, or 100 bikes next month, how are you going to believe it? What is the base to believe that output? That is where we have statistics. The statistics in machine learning are there to evaluate machine learning output, measures the machine learning output, validates machine learning output. There are different types of statistics like accuracy, precision, recall, F1 score, then area under the receiver. Another one is operating characteristics curve, ROC. Then techniques such as cross validation and train test splitting data. We will discuss this one. What is this train and test data? You require a data. Here you see the input data, what you have seen. This data we will split into two types. One, data for training the model. I told you algorithm will run on this data. That requires training data. Another data is required to test it. So two types of data, train data, test data. Those will go as input to model. Anybody has any questions here on these features? No questions?
So I have a question in model and a validation process.
Yeah. So model says 10 bikes can be rented out next month. How are you going to believe? What is the model accuracy? Is it 10%, 20%, 30%, 90%? That accuracy level can be measured by statistics. That model accuracy level can be measured by statistics. Yeah. Ask your question.
Yeah, are we going to use any ETL here?
ETL, yes, because we need to have a data to be extracted. Somebody says,
Because I'm looking at it's unstructured data.
correct. Correct. That is where we are going to work on it.
Okay.
ETL. So we will need to extract the data, right?
Yeah.
To extract data, we require a coding, ETL coding. Got it?
Yeah. Yes, you can continue.
Yeah, we will discuss that also. That's where we have a data pre-processing activity. Here, this is the part of ETL. Okay. So now we know what is the features, what is the label, what the model contains what is the loss function, what is the optimization algorithm, like reducing the loss function, increasing the model performance. Then how you do feature engineering, how we evaluate the model output. Then hyperparameter tuning. Hyperparameters are parameters which controls the learning process of machine learning. Learning means execution process of the algorithm. This is the external parameter. This is depending on the hardware which you are using. For example, you are having a low configuration laptop, your performance will be less. You are having a high-end configuration machine, your performance will be much faster. Similarly, the algorithm, if algorithm running on production grade hardware, you can expect a high learning rate. Or normal level, normal hardware, you can expect a less learning rate. Learning rate means execution rate. So this is the one of the external parameter which will influence the machine learning model output. Then model complexity also. How complex is your model? So that's where you need to go back and work on simplifying that model. Then something called regularization strength. We will be discussing that regularization strength. Don't worry much. But these are the external parameters to the model. You are going to work with these models outside of this code. Nothing related to the code. Okay. So hyperparameters nothing but it is like a combination of hyperparameters to maximize the model performance. Like learning rate, regularization strength, and model complexity. These are the external parameters. So bias variance means, see, let me tell you one important thing. Whenever you go for machine learning, the first thing comes into picture is bias. There will be a lot of bias because it is a machine. It is made up with some assumptions, some data which may not be right, 100% right. So that is where we need to work on how you reduce your bias. Like bias may be like this. There will be some cases where the accuracy level can be 95%. There will be some cases accuracy level cannot be 95%. Maybe acceptable is 60%. If somebody come and says, let's say, within 18 years, somebody can get IAS, can become IAS officer. Very, very lean and least chances, right? You don't believe it. You have a gut feeling. You know that that is not possible. You can upfront say that that is impossible, or 95% is not possible. Correct? So that is called oversimplification or overfitting model. There will be some cases, at least you can expect some good percentage, but it is not performing up to that, even up to that mark. Somebody has to be passed at least 35 marks. If less than 35 marks, you'll fail. That is called underfit. Overfitting, underfitting. Overfitting means overperforming, more than expected things. exaggerations. Underfit means what's supposed to perform, not performing. That's called underfitting. This overfitting, underfitting happens because of data only. Because of data only. That we will be discussing. What kind of data will cause overfitting? What kind of data will cause underfitting practically? Got it? All right. Then we have understood some of the basic concepts of machine learning, like a key common features, labels, model loss function optimization, feature engineering, evaluation, hyperparameters, and bias variance. Next is type of supervised learning. This is one of the types of machine learning. This one. We are discussing this. We understood the machine learning. Then what are the things required for machine learning? Then we are entering into types, supervised learning. What is this supervised learning? Supervised learning involves training the model on a labeled dataset. What is this labeled dataset? Let me explain with some basic example. You are given a fruit basket and you are informed very clearly that there are apples, grapes, mangoes, oranges. Then you are asked to categorize those fruits. Then you can immediately go to those fruits and you'll be able to categorize them, because you know that how apple looks like, how grapes look like, how oranges look like. Correct? You already have that information in your brain, historical data. You already learned from society, from parents, from teachers, from books. There are many ways of learning it. Because of that information, because of that labels, I changed my word. Because of labels, labeled data is already there with you. Based on that, you will be able to categorize them. This is called supervised learning. Let me take another example. Let's say you are asked to identify a fraud detection in banking accounts. There are millions of accounts transactions. You are given those millions of account transactions, ask you to identify fraud happened or not happened. In that case, they say that, boss, these are the accounts, but we have a different accounts like savings accounts, current accounts, family accounts, NRI accounts, NRE accounts. These are all the different types of accounts what we have. Fixed deposits, debt funds, mutual funds, like that. So those are called labels. You know what is savings account, you know what is current account, you know what is mutual fund account. Got it? So the target is always related to this labeled data. Target, what is the target here? Categorizing fruits is the target. Apples one side, grapes one side, oranges one side. So what is the input given? How oranges look like, how apples look like. Those are directly related to category, right? So can I make my statement like this? All label data is linked with the target label. All input data is linked with the target, associated with the target. Am I clear?
Yes, sir.
Only one yes I heard. Remaining yes. Or anybody can give an example. No examples?
In e-commerce website, they categorize according to applications and devices, mobile.
Yeah, exactly. Okay. Now we are at least have some idea about supervised learning. Supervised learning, blindly we can say labeled data is given. We have a labeled data. And that labeled data is linked with the target. What needs to be achieved. See, to be able to identify fraud, you require which device has been used to do the transaction. Correct? Or in which location the transaction has happened. Or how much amount. These are all linked, right, to the output. Based on this, at least you can get some insights to understand whether fraud happened or not happened. So this is about supervised learning. Okay, so we will stop here. So we will connect on Monday. As I told you, all these sessions are Monday to Friday. Okay. So Saturday, Sunday off. Kindly go through the videos again and again. Once again, I have been requesting you that apart from class duration, you require to spend at least 2 hours to understand, to get connected with all my classes, to get transformed. Don't depend on 100% on the class itself. See, this will definitely give you complete end-to-end information, but we are all human beings. Our brains may remember only for sometimes few hours, sometimes few days, sometimes few months, few years. It all based on your individual efforts. So individual transformation happens based on the individual efforts. Remember that. That effort you should only put, no one else. So I'm here to give all necessary inputs, whatever is required. Okay. So thank you so much. We will again connect on Monday.